Okay, let's give you some more practice. So here we've got three functions here. F of x equals this, g of x equals this, h of x equals this. Find the domain for this composite function here. So looking at this here, you've got to put h of x, which is this thing here, put it into the g of x here. So you've got to put this into here, and then put the combination of the two into the f. So you've got to put the combination of the two into f here. So here, this function here breaks down. Remember that this thing here breaks down when you put 0 into here. This one here breaks down when x here is a negative number, and this thing here breaks down when you put the number 2 into here. Okay. Well, anyway, find the domain for this composite function here. So press pause and have a go. Okay. So to do this here, let's well, because we are putting this into the g of x and then putting the combination of the two into the f. Let's look at this one first. So when is it that this function breaks down? Well, this function here breaks down when x equals 0. So just for the time being, just imagine that the domain for this function here could be anything on the real number line, 1, 2, 3, 4, 5, -1, -2, -3, and so on. Well, the domain for this function here is anything on that real number line except from the number 0. Okay, so for the time being, just remember that the domain for this function here is given by this. Okay, now come to put h of x into the g. So we've got to put this here into here. So it will look like this. So g h of x will look like this. Root will look like root 1 over x, because we are going to put this into this thing here. Okay. Now you've got to ask yourself, when is it that this function here breaks down? Well, it will break down when this bubble here equals when this bubble here is less than 0. So now well, this whole function here breaks down when this bubble here is less than 0. So the next question is the next question to ask is, when is it that this bubble equals when is it that this bubble here is less than 0? So visualize the y equals 1 over x graph. So the y equals 1 over x here. The y, we'll visualize this graph here, the reciprocal graph. You see on this side here it will be negative. So the domain for this function here will be anything where x is greater than 0. Okay, so the domain for this function here is anything greater than 0. So if you look at this here, so if you look at the number line, hang on. So far, looking at the number line, we are going to put this into here, and the domain for that would be 0 or 1, 2, 3, 4, 5, and so on, -1, 2, 3, and so on here. Well, the domain for when you put this into here, the domain for the combination of the two here would be anything greater than 0. So it cannot be the number 0 itself. It's greater than 0, so it could be anything to the right. And the domain for this function only would be this. Hang on, would be anything. Well, 0 here, 1, 2, 3, 4, 5, and so on. Negative. Well, the domain for this function only would be anything on that real number line except from the 0. The domain for the combination of the two here is just to the right, and it cannot be the number 0 itself. Okay. So now so now we've got to look. Hang on. So let me clear this up. So now we've got to put this into here, and then put the combination of the two into here. So overall, this function here, well, when you put this into here, and then the combination of the two into here, it will look like this. So this function here equals this, equals 1 over, well, remember that when we put this into here, it looks like this, 1 over x here. So this thing here, we've got to put it into here. So so it will look like this, root root 1 over x and then minus 2. Okay, so this complicated function here is this thing here. Now you've got to ask yourself, when is it that this whole thing here, when will it break down? Well, it will break down when this thing here equals 0. So the next question to ask is, when is it that this thing here equals 0? Well, this whole thing here equals 0 when this thing here is a positive 2. So this, yeah, so this function here breaks down when this thing here is a positive 2. So it boils down to us asking ourselves, when is it that this thing here equals 2? Okay, so basically, hang on, this function here will look like this: 1 over root 1 over x and then minus 2. So when you put this into here and then the combination of the two into the x here, it will look like this. Okay, well, this whole function here breaks down when this equals positive 2. So you've got to ask yourself, when is it that this equals 2? Well, it will so it boils down to this question here: 1 over this equals 2. This is when the whole function breaks down. You see, when this here equals 2, then the whole function breaks down. So try and solve this this equation here. So square both sides. So that will be 4 equals this, and then take the reciprocal of both sides. So x here equals a quarter. So this function, this whole thing breaks down. This whole thing here breaks down when x equals a quarter. Apart from that, everything's alright. So remember, this thing here breaks down when you try and put a quarter into the x. Okay, because yeah, so it breaks down when you put a quarter into there. So overall it will look like this. Hang on. So remember that up here, if you the domain for up here would be wait there, 1, 2, 3, 4, 5, and so on. It could be anything apart from the number a quarter. So the domain for the whole thing here would be x can be anything on the real number line except from a quarter here. So hang on, let me try and draw this. Hang on. So you've got your number line here, 0, 1, 2, and so on here, -1, negative. It can be, the domain here could be anything except from, it could be anything except from the quarter. Okay, the domain for gh of x here would be hang on, let me draw the number line, 0, 1, 2, 3, and so on here. The domain for this would be anything to the right. So it was like this. Okay, and the domain for this one here, well, let me draw the number line here. It would be 0, 1, 2, 3, and so on, -1, -2, and so on here. The domain for this bit here would be, well, it could be anything except from the number 0 itself. So it could be, the domain for this here would be, so now to find the domain for the whole composite function is basically the intersection, if you like, of the three domains here. So if you select a negative number, it's okay here, but then this here will break down. It's okay here. Yeah, so you cannot have a negative number. If you choose the number 0 itself, you see this here breaks down when you and also this here breaks down as well. So you cannot choose the number 0. So and then if you look at a quarter, this thing breaks down. It's okay here, it's okay here, but you cannot. So looking at all three as a whole, you cannot have You cannot have a negative. You cannot have a negative number. You cannot have the number 0 itself, and you cannot have the number a quarter. Okay, so basically the domain for the whole thing here. Hang on, just bear that in mind. You've got to take all three here into account. So it's basically a number greater than 0, but a number greater than 0, but it cannot be a quarter as well. So when you come to write this, the domain for this function here would be well, x could be anything on the real number line, okay, but x has to be greater than 0, and it cannot be the element of a quarter here. And there are lots of ways of writing the domain of something. So make up your own notation if you like. So here, just remember. There are lots of ways of expressing this. Basically, it's saying anything on the real number line, but x has to be greater than 0, but don't select the number or quarter. And there are lots of ways of writing the domain. So choose your method. Okay.